Video we are going to discuss about the different types of turbine. Myself I am Rajakumar, Assistant Professor, Department of Mechanical Engineering, Rogini College of Engineering and Technology. After studying this topic, students can able to evaluate the performance of steam turbine through velocity triangle, understanding the need for governing and compounding of turbines. Highest coins level K5. What is turbine? A turbine is a rotating part which converts kinetic energy of working fluid into useful mechanical energy and or electrical energy. Simply, right? Well, nothing is simple. When you go deeper, there are set of blade mounted on a rotor which help in extracting energy from the moving fluid. The efficiency of turbine depends on the design of the blade. Different applications need different designs, and designing them is not a layman's job. So next, different types of turbine. So there are four types of turbines: water turbine, steam turbine, gas turbine, and wind turbine. First of all, we are going to see about the water turbine. The turbines used in hydroelectric power plant or water turbine, which have water as their working fluid. First of all, million of liters of water is collected in the dam. More the height of dam, more the pressure, the highly pressurized water is then made to flow via large pipe called penstock. The turbine is located at the end of the penstock from where the pressurized water strike the blade of turbine at high velocity, making it to rotate. The turbine is connected to a generator which generate the electricity. The shape of the turbine blade depend upon the pressure and velocity of water. Water turbine are classified into two types. One is impulse turbine and another reaction turbine. So impulsion turbines basically works on Newton's second law. Impulse turbines number of elliptical half-size buckets are fitted inside of blades on the rotor hub. When water strikes the bucket at the high speed, the rotor rotating in short. The kinetic energy of water get converted into rotating mechanical energy. Thus, electricity is generated when one end of turbine shaft is connected to generator. Example: Belton turbine. The reaction turbine means the turbine blades or the impeller blades are designed in such a way that the force is generated on one side when water flows through it just like an airfoil. The force produced by airfoil is responsible for lift of aeroplane. Similarly, here the force make the blade rotate. Example: Kaplan turbine. So different types of turbines have their own ideal operating conditions. For example, Belton turbines are preferred where the large discharge rate can be obtained and high kit, that is 80 to 1600 meter is available. The Kaplan turbine required high discharge rate along with low or medium head 2 to 70 meter. Francis turbine work on medium flow rate and medium head. Francis turbine is combination of impulse and reaction turbine. So Francis turbines are mostly widely used in turbines because they are highly efficient and could also work in wide range of operating conditions. So 1 meter head of water equals 980 at 9810 Pascal. Then steam turbine. We are going to see about the steam turbine. The steam turbine they are used in steam turbine is nothing but like a water turbine, but here the steam is used to operate the turbine. They are used in nuclear and thermal power plant where water is heated to form the steam and then flowed through turbines to produce electricity. Like water turbine, steam turbines are also classified into impulse and reaction types of, but arrangement and design is different. All the modern steam turbines are the combination of impulse and reaction type turbines. Okay, this is the diagram shows the steam turbine. Next, we are going to see about the gas turbine. The gas turbine, in other words, are internal combustion engine which are not only used in power plant for generating electricity but also propelling the airplane and that is aeroplane and helicopters. The gas turbine as a whole system has an axial compressor at the inlet. These are set of rotating blades which suck a huge amount of air and compress it, which also increase the temperature. The air is then supplied to the combustion chamber, fuel is added to the combustion chamber and ignite the fuels. Thus large amount of exhaust gas are produced which are made to flow through the turbine. The example for gas turbines are turbojet and turbofan, turbojet and turboshaft and ramshaft. Then wind turbine. The wind turbines are a boon to mankind, affordable, clean and sustainable. Some wind farms are also big that they could produce 50 megawatts of power. Well, coming to uh, working of wind turbine, the story remains same as the other turbines. The rotor has three blades or designed in such way that when wind flows right through them, they start rotating. The only problem here is wind turbine rotate at very low rpm. The low rpm does not produce electricity of record frequency, and that is why we are record a gearbox which increase the speed of shaft. The output shaft is then connected to a generator. The three types primary types of wind turbines are horizontal active wind turbine and Savinow's vertical axis wind turbine, then various vertical axis wind turbine. Thank you.